How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for the periodic table, molecular compounds, as well as ionic compounds. So let's take a look. What elements will have similar properties as calcium? Well, if we take a look, let's find calcium, right? Now, the periodic table has elements grouped into what they call groups vertically. So what determines which elements are going to be in the same group? It's if they have similar properties. So which ones have similar properties to calcium? Anything in group 2. So it could be beryllium, magnesium, strontium, barium, radium. All those things would have similar properties to calcium. What are the elements in groups 1A, 6A, and 7A called? All right, so 1A, these are the alkali metals. Group 2, alkaline earth metals. If we jump over to 6A, which is group 16 right there, those are called the chalcogens. And 7A, or group 17, are the halogens. So there. Which compounds do not have the same empirical formula? So for this one, you're going to have to solve what are the empirical formulas. Well, C4H8, 4 and 8 can both be divided by 4. I end up with CH2. C3H6 can both be divided by 3, and I end up with CH2. So those ones are the same. C2H4O2, all that can be divided by 2, and I end up with CH2O. And let me check. C6H12O6, all could be divided by 6, and I end up with CH2O as well. So those ones are the same as well. C2H2 and C6H6 are both going to end up being CH. Now this one's kind of obnoxious because they have carbons written in multiple different places. So this is actually like C4H8O2, which I can simplify to become C2H4O. Now this one has a similar problem. So it's really C2H4O, and that is also the empirical formula, and they match, so they're the same as well. And then CO and CO3. Well, CO3 can't be simplified anymore, so these ones have the different empirical formulas. For which of the following is not an ionic compound? So here are our options. Now remember, ionic compounds form when a metal and a nonmetal bond together. So if we take a look, here are our stairs. All the ones in brown are those metalloids. And they're kind of the in between the metals and the nonmetals, but everything on this side of it, nonmetal, and everything on this side of it will be the metals. So which one will give you an ionic compound? NaCl? Well, sodium's a metal, chlorine's a nonmetal, so it could be that one. MO and Cl. Yeah, molybdenum is a metal, Cl is a nonmetal. PbCl2, metal and a nonmetal. RbCl, metal and a nonmetal. PCl5, well, let's see, P's right here, it's a nonmetal. Chlorine, also nonmetal. So this one, not going to be ionic. All right, which of the following elements is a nonmetal? So again, the nonmetals are on the right side of this staircase. So let's see, boron, it's a metalloid, so that's not a nonmetal. Astatine, also a metalloid. Phosphorus, that one's a nonmetal. Silicon, metalloid. Strontium is a metal, so boom, choice C is a nonmetal, phosphorus. 6. Which of the following does not occur as diatomic molecules in its elemental form? So remember, diatomic means 2 atoms, and they are the Brinkelhoffs. BRINCL, HO, and F. Which means bromine's never just going to be bromine. It's going to be Br2. Iodine, I2. All of these are going to show up with pairs. They ain't going to ride solo, you know? So which one of these does not occur? Well, which one of those isn't a Brinkelhoff? Sulfur. All right. All right, 7. Blank typically forms ions with a +2 charge. Well, +2 charge, the plus is going to tell me that it's going to be a metal. Metals like to lose electrons and become positive. How many are they losing? 2. So which group wants to lose 2 electrons? It's going to be group 2. Because when they lose 2 electrons, then they get to hang out and start looking like a noble gas. Right? Magnesium has 12, whereas neon only has 10. So if magnesium lost 2 electrons, it become +2. So any of these in group 2 would be good answers. 8. How many protons, neutrons, and electrons are there in an I-131 minus ion? Note that there is a charge. There's a -1 there. So what does that tell me? Well, if normally protons equals electrons when it's neutral, how can I get a negative charge? Well, they must not be equal. Instead, there must be more electrons than protons. How many more? It's however much the charge is. If it's -1, then just one more. So let's take a look. Iodine is over here. It has a mass of 131 and an atomic number of 53. Well, that tells me I have 53 protons. Now, electrons, if the charge is -1, they must have one additional electron, so there'd be 54 electrons. And neutrons, well, you got to take the mass and you got to minus the number of protons. Because electrons are so small that we just say there is no mass and we'll still get the right answer. So the mass of an atom is really just the protons and the neutrons. So if I want the neutrons, it's mass minus protons. So it's 131 minus 53. And oh man, I'm struggling. 78 is how many neutrons I got. So there you go. 78 neutrons, 53 protons, and 54 electrons. 9. What is the formula of a compound formed between strontium and nitrogen ions? So let's find them. I got strontium and I got nitrogen. Again, strontium is in that group 2, so it's going to become +2 charge. It wants to lose those 2 electrons so it could start to look like krypton. Nitrogen, the nonmetal, wants to gain electrons. How many? Well, if it wants to look like neon, it's going to have to gain 1, 2, 3 electrons. So it's going to be -3. So to figure out the formula, you can do the little trick of swapping and then simplifying. You go, hey, if strontium's +2, bring that 2 over to the nitrogen. And if nitrogen's -3, bring that 3 over to the strontium. And always check. If each strontium's +2 and I have 3 of them, that tells me I have +6 from those strontium. If each nitrogen's -3 and I have 2 of them, that tells me I have -6. When I add those together, I get an overall charge of 0. I'm good to go. 10. Aluminum reacts with a certain nonmetal and forms a compound with the general formula AlX. It's also a diatomic gas at STP, standard temperature and pressure. What must X be? Well, let's take a look at aluminum. It's a metal. It has 13 electrons. Neon, the previous noble gas, only has 10. So aluminum is going to become +3. It's going to lose those 3 electrons, becoming a +3 charge so it can look like neon. All right, well, that must mean if the X, it's just 1 aluminum to 1 unknown, it must have a -3 charge, which tells me I'm going to be looking for nonmetals in this group 15. It also tells me that it's a diatomic gas at STP, so I'm looking for one of the Brinkelhoffs, BRINCLHO or F. And let's see, I got nitrogen in there, and that's the only Brinkelhoff, so it's got to be nitrogen, right? 11. Predict the empirical formula of the ionic compound that forms from aluminum and oxygen. Again, we just said that aluminum is going to be +3. Oxygen is going to have to gain 1, 2 electrons, so it's going to be -2. You can take the number and do the old swap and simplify. So I end up with Al2O3. I can't simplify 2 or 3, but let me check my charges. Each aluminum's +3, so I get +6 from those aluminum. Each oxygen's -2. Means I get -6 from all the oxygen. Gives me a neutral compound overall. So it's Al2O3. 12. What is the empirical formula for a compound formed between magnesium and oxygen? So magnesium is going to lose 2 electrons, so it could look like neon. So I'm going to end up with Mg plus 2. Oxygen is going to have to gain 2 electrons, so it's going to be oxygen minus 2. I can do the switch and simplify. I get Mg2O2 and simplify. They're both 2, which means I can simplify them to just be MgO. There you go. So yeah, I hope you found that helpful, and I'll see you in class. Okay, bye.